Hello, viewers. In today's session, we are going to discuss another important problem from application of derivatives. And here we are going to take up one problem from increasing and decreasing functions. So here we have this problem where we have to find the interval in which this function f of x, which is equal to tan inverse x minus half times natural log of x, is decreasing, right? So we have to find out all the values of x for which this function is decreasing. So here we'll take help of the concept of derivative, and we'll find out the interval where this function is decreasing. So let us start. So now from the definition of a decreasing function, we know that if we have a function, say y is equal to f of x, which is defined in some domain D, then this function is said to be a decreasing function if the derivative, that is f prime of x, is less than 0 for all x belonging to this domain D, right? So if the derivative, that is dy over dx, is negative, or the slope of the tangent at the given curve is less than 0, then the function y is equal to f of x is said to be decreasing at the given point, right? So if dy over dx is less than 0 for all x belonging to the domain D, then the function is said to be a decreasing function. So here we'll apply this definition of decreasing function to find the interval, right? So let us first quickly look at this function. So here we have tan inverse x, and here we have minus half times natural log of x. Now the domain of this function is given by all x greater than 0, because we know that tan inverse x is defined for all values of a real number, but here we have natural log of x, so here x should be strictly greater than 0, because the natural log of positive numbers is defined on the set of real numbers. So here the domain of this function is x greater than 0. So now the next step is to find out the derivative of this function. So we have f prime of x, that is equal to d by dx of tan inverse x, and then we have minus half and d by dx of natural log of x. So the derivative of tan inverse x is 1 over 1 plus x square, and here we have minus half, and the derivative of log of x is 1 over x, right? So now let us simplify this expression. So we can now take here 1 plus x square, and then we have here 2x, and now taking the cross multiplication, here we have 2x minus 1 plus x square. So now we can write this numerator as taking the negative sign here common. So we can now write here 1 plus x square, and then we have minus 2x, and here we have 1 plus x square, and this is 2x. Now see this expression, that is 1 plus x square minus 2x is given by x minus 1 whole square. So here a minus b square is equal to x square plus 1 minus 2x. So here we have a minus b square, that is a square minus 2ab plus b square. So now we can write here minus, and here we have x minus 1 square, and we have 1 plus x square, and here we have 2x. So the expression for the derivative that is dy over dx, or f prime of x is given by this expression. So now this function is decreasing if the derivative f prime of x is less than 0 for all x belonging to the domain, right? So here we should have this expression should be less than 0. So we should write here minus x minus 1 square, and here we have 1 plus x square, and here we have 2x, and this should be less than 0. So now from this inequality we can easily conclude that this expression that is 1 plus x square is always greater than 0, because here we have x square. So this term is always going to be positive for all x greater than 0. So 1 plus x square should be greater than 0, and similar is the case with this expression, that is x minus 1 square is again greater than 0 for all x belonging greater than 0. So x minus 1 being a square term here, x minus 1 square, so this is always going to be greater than 0. So this term is positive for all x greater than 0. Similarly, this term is also positive, right? So now we have here from this inequality we have the negative sign, and here we have a positive quantity, and in the denominator we have here positive, and this is 2x, right? And this is less than 0. So here minus times plus is minus, so we have minus 1 over 2x less than 0, right? So now this expression is less than 0 when x is greater than 0, because when x is positive, then only minus 1 over 2x is less than 0. So the derivative f prime of x is less than 0 whenever x is greater than 0 or x is positive, because here we have a negative sign, right? So here we should have a positive sign because the derivative has to be less than 0. So this function f of x is a decreasing function when x is greater than 0, and we can see that here x greater than 0 also constitutes the domain of the function, right? So f of x is decreasing function whenever x is greater than 0 or x belongs to this interval, that is 0 to infinity. So here minus 1 over 2x is less than 0 when x is greater than 0, that is x is positive, so that this entire term is negative and it remains less than 0. So therefore this function f of x is decreasing for all x greater than 0 or x belonging to the interval 0 to infinity. Hello viewers, in today's session we are going to discuss another important problem from application of derivatives, and here we are going to discuss this problem which is related to the concept of increasing and decreasing functions. So here we have to show that the function f of x, that is equal to 3 times cos square x minus half, is decreasing on this interval, that is 0 to pi by 2, right? So here again we'll take help of the concept of derivative, right? Now see, we know that a function say y is equal to f of x, which is defined in some domain say D, and if this function is continuous and differentiable in some open interval, right? Suppose this function is continuous in some interval a comma b and differentiable in the open interval a comma b, then this function is said to be a decreasing function if dy over dx is less than 0 for all x belonging to the interval say a comma b, right? So if the derivative is negative, that is less than 0 for all x belonging to this interval, then the function is said to be a decreasing function for all x belonging to a comma b, right? So here we'll apply this concept to this function. So let us first find out the derivative of this function. So f prime of x is given by d by dx of 3 times cos square x minus half, right? And here it is important to note that the domain of this function is the set of all real numbers, right? So here x belongs to the interval, the set that is R. So here the derivative of cos square x is 2 cos x, and then by chain rule we have here minus sine x. The derivative of cosine x is minus sine x, and the derivative of here half is 0. So here we have minus, and then we have 3, and we can now write 2 sine x, and here we have cos x. So now from trigonometry, we know that sine 2 theta is equal to 2 sine theta cos theta. So we can now write here sine 2x. So the derivative of f of x is given by minus 3 times sine 2x. So now if this function f of x is to be a decreasing function, then the derivative, that is f prime of x, should be less than 0, right? But here we have a negative sign, that is we have a minus 3 sine 2x. So here we are concerned with only the sign. So here we have the negative sign. So f prime of x should be less than 0 for f of x to be decreasing. So it implies that sine 2x must be greater than 0, or sine 2x should be positive, right? Because when sine 2x is positive, then f prime of x is given by minus 3. So here we are considering only the sign. So we have here the negative sign, and then if sine 2x is positive, then the product of negative and positive is negative. So in that case only f prime of x is less than 0. So now let us consider the sign of sine 2x in the interval that is x belonging to 0 to pi by 2. So x belonging to 0 to pi by 2 implies that we have x greater than 0 but less than pi by 2. So now here we have 2x, and we have to determine the sign of sine 2x. So let us multiply this inequality throughout by 2. So here we have 0, here we have 2x, and here 2 and 2 get cancelled, so we have pi. So now 2x lies in the interval that is 0 to pi. So if we see the sign convention of sine function in the four quadrants, here we have 0, here we have pi by 2, here we have pi, this is 3 pi by 2, and here we have 2 pi. This is first quadrant, this is second, this is third, and this is fourth. So when x belongs to 0 to pi by 2, then 2x belongs to 0 to pi. So we have to consider only the first quadrant and the second quadrant. So we are in the first or second quadrant, and from the sign convention of sine function in the four quadrants, we know that sine function is positive in the first quadrant and in the second quadrant, and it is negative in the third and fourth quadrant. So now we can conclude that sine 2x is greater than 0 when 2x belongs to 0 to pi. That is, sine 2x takes the value either in the first quadrant or in the second quadrant, right? So here the angle that is 2x belongs to 0 to pi. So sine 2x is greater than 0. So now here sine 2x is greater than 0, that is it is positive, and here we have already a negative sign due to the derivative, and the product of negative and positive is negative. So f prime of x is less than 0 for all x belonging to 0 to pi by 2, and it suggests that this function f of x is a decreasing function or a strictly decreasing function on this interval 0 to pi by 2. Hello viewers, in today's session we are going to discuss another important problem from application of derivatives, and here we are going to take up an important problem from the concept of increasing and decreasing functions. So here we have to prove that this function f of x, that is 2 times cos x and here cos square x over 2, is a decreasing function on this interval that is 0 to pi by 2. So in order to prove that this function f of x is a decreasing function on this interval, we have to take help of the concept of derivatives, right? So here we'll take up the definition of decreasing function in terms of derivatives. So suppose we have a function, say y is equal to f of x, which is defined in some domain D, and if f of x is a continuous function in the interval, say a comma b, and it is derivable in the open interval a comma b, then this function is said to be a decreasing function if the derivative, that is f prime of x, is less than 0 for all x belonging to this interval, that is a comma b. So dy over dx has to be a negative quantity, or it is less than 0 for all x belonging to a comma b. So here we'll utilize this definition of decreasing function. So let us first rewrite this function f of x using an important trigonometric identity. So let us first write f of x as here we have 2 cos x, and here we have cos square x over 2. Now from trigonometry we know that cosine 2 theta is equal to 2 cos square theta minus 1. So taking minus 1 to this side, we have cos 1 plus cos 2 theta is equal to 2 cos square theta. Now if we replace theta by 2, then we have this expression 1 plus cos theta is equal to 2 times cos square theta over 2. So here we have 2 cos x cos square x over 2. So let us combine 2 and cos square x over 2. So here we have 2 cos square x over 2, and here we have cos of x. So now using this identity, that is 1 plus cos theta is equal to 2 times cos square theta over 2, we can now replace 2 cos square x by 2 by 1 plus cos x, right? And now if we multiply 1 plus cos x with cos x, then we have cosine x times 1 is cosine x, then we have here cos square x. So now our function f of x, it can be written like this using this identity, right? So now let us find out the derivative of f of x with respect to x. So f prime of x is equal to d by dx of cosine x, and then we have d by dx of cos square x. Now the derivative of cos x is minus sine x, and here we have the derivative of cos square x as 2 cos x, and then by chain rule the derivative of cos x is minus sine x. So now we have minus sine x, and here we have minus 2 sine x cos x. So now let us use this identity, that is sine 2 theta is equal to 2 sine theta cos theta. So here we can now write minus sine x, and then we have minus sine 2x. Now taking the negative sign common here, we have minus, then in the within the brackets we have sine x plus sine 2x. So the derivative of f of x is given by this expression, and now for fx to be a decreasing function, the derivative should be less than 0. So now let us see this interval. So here x belongs to 0 to pi by 2. So this suggests that x should be greater than 0 but less than pi by 2. Now here we have the combination of two terms, that is the sum of sine x and sine 2x, right? And when x it is greater than 0 but less than pi by 2, it implies that we are in the first quadrant, right? And from trigonometry we know that the sine function is positive in the first and second quadrant, and it is negative in the third and fourth quadrant. So here we have pi by 2, here we have pi, this is 3 pi by 2, and here we have 2 pi. So according to the sign convention of trigonometric functions in the four quadrants, the sine function is positive in the first and in the second quadrant, that is from 0 to pi the sine function is positive, and from pi to 2 pi, that is in the third and fourth quadrant, the sine function is negative. So here we are going to decide the sign of f prime of x using the sign convention for the sine function, right? Because here we have the sum of two sine functions. So now we have x greater than 0 but less than pi by 2. So let us multiply this inequality throughout by 2, because here we have sine 2x. So we need to find out the interval for the angle 2x. So here we have 0, that is 2 times 0 is 0. Here we have 2x, and here we have pi, because 2 and 2 get cancelled. And this inequality suggests that x belongs to the first quadrant, that is from 0 to pi by 2, and this inequality suggests that 2x belongs to the interval or the quadrant that is either first quadrant or second quadrant. So here we have first or second, right? So in both the cases, that is when x belongs to the first quadrant and 2x belongs to the interval 0 to pi, sine x and sine 2x both are going to be a positive, right? So let us once again explain it. So here we have sine x, and here we have sine 2x. Now x is greater than 0 but less than pi by 2. So x is in the first quadrant, and in the first quadrant sine x is positive, right? So this quantity is positive, and 2x, when we multiply this inequality by 2, then we have 2x greater than or less than pi. So 2x belongs to either in the first quadrant or in the second quadrant. So sine 2x is again positive, because 2x lies in the interval that is 0 to pi. So here we have the sum of two positive numbers, right, for all x belonging to this interval. So now we can write f prime of x is equal to minus, and here we have a positive number for all x belonging to the interval 0 to pi by 2, and here sine 2x is again a positive number. So we have minus, and the sum of two positive numbers is positive, and when we multiply negative and positive, then here we get a negative sign, and this suggests that f prime of x is less than 0. So this function f of x is a decreasing function on this interval 0 to pi by 2, because f prime of x is equal to a negative number for all x belonging to 0 to pi by 2. That is, f prime of x is less than 0 for all x belonging to 0 to pi by 2. So as per the definition of a decreasing function, a function is said to be a decreasing function if f prime of x is less than 0 for all x belonging to the interval a comma b. So this is how we can prove that this function is decreasing function on this interval.